Hello and welcome to my video, lesson 7.2 on absolute value equations. So being that it is an equation, equations contain one and only one variable because you can solve an equation. Okay, the two sides are equal to each other. So one and only one variable. So we're looking to solve, usually we would write x, okay? But it could be any letter, any variable, okay? And basically, we're solving for the intercept of the two different equations, so where they meet algebraically or graphically. So depending on what the question might ask you on an assignment or a test, you'll have to do it the different methods. So let's do it graphically to start. So I'm going to show you guys the first one, and then you guys can go ahead and pause the video, try it out for yourself. You can try all of these graphically, and then after you do that, you can try these ones algebraically with me. All right, so the first one, I put in the left side as the blue, i.e. the first equation, and the right side is going to be the red. Same thing here is what I'm going to do next time. So here you go, absolute value x and 3. So now we get this equation. We can go second function trace or calc, and then number 5, which is our intersect. So then we go to the different points. So here's one of them. We click enter, enter. So that's first curve, second curve, and then we guess that point, and it tells us that the intersection is x equals 3. We can also try that again. Second function calc, intersect, and then move over. Oops. Till there, enter, enter, enter. And we'll notice that x is also negative 3. So it's positive or negative 3, which kind of makes sense. If we were to try plugging these values in, no matter what we put in for x, once you use the absolute value, it still equals 3. So you can also always verify your answers. All right, let's try the second one. 2x is 6. So here we have this equation. We can solve this algebraically or graphically, but we are doing graphically right now, so we're finding the intersect. So we go over here, we press enter, 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 and we get 3. Oh, it's going to be the same. Negative 3 is going to be the other one, but there you go. Yeah, negative 3. Okay, you could verify it by putting it in, but yes, it works. Okay, now let's try some algebraically. And we're going to need a little bit more space. We'll see. All right, so the goal here is to solve for x. So what do we do with this absolute value bracket? Well, what we need to do is we need to move it over to the other side by doing case number 1 and case number 2. So the first one is where we have a positive 1 multiplying, so nothing changes. So this is case number 1. And case number 2 is where a negative 1 is being multiplied. So we just flip the sign on the other side or on one of the two sides, as long as you pick only one of the two sides. Okay, so let's go ahead and try to solve the top one. Okay, so let's solve the bottom one here. I think I just made a little mistake here. So this will be 2x if we put all the x's to this side, and this side will have negative 2. So x equals negative 1, so if you divide by 2 on both sides. Okay, and you might see here that the x's kind of cancel, right? And so 1 equals 3. But does 1 equal 3? No, it does not equal 3. So we actually call this an extraneous solution. Okay, so what does that mean is it's extraneous? What does that mean? So if we plug it in to our graphing calculator, x plus 1, and then we put x plus 3, you're going to notice something. There's only one intersect, so why would we have two solutions? So that's why we're going to have these cases where we'll have some extraneous solutions. So notice that if we graph it, it makes sense that it didn't work out, right? That it only has that one spot. Okay, so did I do something? Oh, that's what I did wrong. Like, what did I do wrong? Okay, I made a mistake here. This should be a negative 4, and then so this should be a negative 2. The graphing calculator should tell us the same answer. Okay, let's try the next one. If you want to pause the video before trying this one, that would be a great idea. All right, I'm going to go ahead and try this out. Pause the video if you haven't had a chance yet. So first thing we're going to do is move the 2 over. That's pretty easy to do. But once we do that, then we can, well, maybe let's just do that in black so we can keep that separate. So 2x plus 3, and then if we move the 2 over, we have 3 on this side. Okay, so now we're going to have our two cases. So our first case is 2x plus 3 equals 3. And then our second case is going to be 2x plus 3 equals negative 3. Okay, so now what we can do is this blue situation, we're going to solve for x. So we're going to move the 3 over, so we're going to have 2x equals 3 minus 3, which simplifies to 0, and 0 divided by 2 is still 0. Okay, looking at this next case, we have, we can move this over, which then gives us negative 6 on this side. So 2x equals negative 6. So then we can move the 2 over, so we get negative 3 is our final answer here. Okay, now what we have to do is we have to take those and substitute them in to see if they are extraneous or not. The one possibility is, if the x's cancel, but we could still have an extraneous root. So let's just try subbing it in to see if that works. So if we sub it in to the beginning, so then we get 2 times 0 plus 3 equals 3. So that would be, does that equal 3? Yes, it does. Okay, now let's try plugging the other one in, the red option. Let's plug it in, so that would be negative, well, let's 2 times negative 3 plus 3 equals 3. So that would cancel, that would be negative 3 equals 3, and yes, that works. So both of those should be solutions. We can again check this out by plugging it into our calculator. So 2x plus 3 plus 2, 5. And you can see there's two different spots. We could check them but I'm not going to right now. Okay, our last one, it is the most complicated. We have a quadratic. We have one with a square here. So what are we going to do? Well, it's going to be the same process. It's just going to take a lot longer. So how can we make this happen? The same process but longer? Well, we have to do two cases. Case number one, well, actually, case number one, we keep everything the same, as we always have. And we try to solve for x. Case number two, we flip it, so we have negative x positive 5. And like I said, you can flip either side. Doesn't matter, as long as you flip only one side. Okay, so now we have our two different cases. Now, once we move all of the values over to the one side, we're going to have negative 9x plus 20, like that. And on the other one, we're going to have x squared minus 7x plus 10. So now we can use PSA, product sum answer. So we'll just put these brackets in place. So two things have to multiply to get 20. So 5 and 4 work. And then, whoops, and then one of them is, or both of them are negative actually, because the sum has to be negative 9. Okay, over here, same sort of process. But this time we have two different numbers, 7 and 10. So 5 and 2 multiply to get 10. And if they're both negative, then it works. So to state it one more time, 4 and 5 are the two answers for that. And x equals 2 and 5 are the two answers for that. Now, we don't know yet if those are right, so we need to, again, plug it in to the original equation. Okay, so this is going to take a little bit of time, but we have to try it out. So 4 minus 5 equals 4 squared minus 8 times 4 plus 15. 4 minus 5, that's negative 1. This is 16 minus 32 plus 15, which is like saying 1 equals 16, 32, 31 minus 32, which is like saying negative 1. And since that is not equal, this one is extraneous. Okay, now we need to try it again, but with the 5. So plugging in the 5, so 5 minus 5, that's going to go straight to 0. 5 squared minus 8 times 5 plus 15. So this is 0, 25, 40, and 15. And yep, that 0 equals 0, so it's good. And then last but not least, we're going to put in the 2 and see if that one's extraneous. It's a process, I get it. 2 minus 5 equals 2 squared minus 8 times 2 plus 15. Okay, this is negative 3. This is 4 minus 16 plus 15. Which gives us 3 here. 19 minus 16 is 3. So this one also works. Okay, and again, if you wanted to check it in your calculator, that wouldn't be too hard. You would start just plugging stuff in. So x squared minus 8x plus 15. And so you get a graph that looks like this, and you can see how the one spot lines up with the 5. I guess we could try tracing it so you could actually see it. Here, we'll get the intersect. So 2 and 3, so that's the 2 position and the 3 that we calculated in orange, right? And in green is our other position, so that's 5 and 0, right there. So our actual answers are 2 and 5 as our final answers. The 0 and the 3 are just the work to show that they actually exist. But the answers themselves are these two, 2 and 5. All right, I hope that this video helps you understand absolute values and their equations a little bit better. Good luck.